Hi everyone, good day. Are you ready for another Math Venture with Teacher Rev? Let's start our statistics learning journey. So let's talk about classical probability. When we say equally likely events, these are events that have the same probability of occurring. This is actually acquired through using the given formula. If each of the outcomes in a sample space is equally likely to happen, then the probability of an event E is the number of ways the event can occur over the number of possible outcomes, which talk about the number of items in the sample space. Let's watch a video regarding
Sample space is often used in getting probability of an event. When a coin is tossed, what is the probability of getting a head? If your answer is 1/2, then your answer is correct. For there is 1 out of 2 chances that the result will be a head. Thus, the probability of getting a head is 1/2. What is the probability of getting a number less than 5 in a roll of a die? If your answer is 2/3, your answer is correct. Because there are 4 possible outcomes when we talk about getting a number less than 5. The result can either be 4, 3, 2, or 1. Which means 4 out of 6 can be an outcome, or 2/3. What is the probability of getting a 2 from a standard deck of cards? If your answer is 1/13, your answer is correct. Note that the deck of cards consists of 52 cards, and out of 52 cards, there are 4 cards which contains 2. 2 of hearts, 2 of spades, 2 of diamonds, and 2 of clubs. Then, the probability of getting a 2 is 4 out of 52. Note that fractions are always written in simplest term. Thus, 4 out of 52 will be written as 1/13. When we perform experiments, just like rolling a die, are we certain that the result will be an even number? If your answer is no, I agree with you. Though there is a chance that it might be an even number and a chance that it might not be an even number. These classic experiments that we did, tossing a coin, rolling a die, are chance events. Chance events because outcome is uncertain.
Okay, so we know about probability. This time, let's continue discussing and giving example of probability. How do we solve for a probability of a certain event? Example 1, if a coin is tossed, what is the probability of obtaining a head? Definitely, this is a classical probability on which getting a head or a tail have equal chance of occurring. So, to answer letter A, the probability of getting a head, we need to identify first the sample space. If a coin is tossed once, therefore, the sample space are actually getting a head or a tail. So there are 2 outcomes, therefore the denominator would be 2. We had this earlier, but I need to make you understand what probability is all about. Out of the 2, there's only 1 chance that it will be head, so the probability of getting a head when a coin is tossed is 1/2. Let's go to letter B. We can write it as probability, then the event. The event is getting a tail. So the event of getting a tail is 1/2. Also, why 1/2? There are 2 possible items in our sample space, so that's 2. And then there's only 1 chance that it will be tail, so the probability of getting a tail is 1/2 if a coin is tossed once. Let's go further. If a die is rolled, what is the probability of getting an even number? Before we answer the probability, let's identify first the sample space. When we roll a die, the sample space are 1, 2, 3, 4, 5, and 6. So there are how many items in the sample space? There are 6 items in the sample space. Therefore, the probability of an item to be an even number, the probability of getting an even number, is equal to a denominator of 6 since there are 6 possible outcomes in the sample space. But getting the event of an even number, there are only 3 chances that it will be even. That is when it's 2, 4, or 6. So since there are 3 chances, then there are 3 out of 6 chance that an even number will occur. Or the probability of getting an even number is, in simplest form, 1/2. Now let's go to letter B. What is the probability of getting a number divisible by 3? The event is a subset of a sample space. Therefore, we have the denominator as 6 because there are 6 possible outcomes. Let's erase that part. But take note that when we say a number divisible by 3, there are only 2 numbers in the sample space that are divisible by 3, and that's 3 and 6. Therefore, since there are 2 items, then that's 2 out of 6 chance that the number will be divisible by 3. So the probability of getting a number divisible by 3 is 1/3. Okay, so I guess probability is getting clear already. What is the probability of getting a number greater than 5? Again, since the activity is the same or the experiment is the same, our denominator is 6 because there are 6 items in the sample space. But getting a number greater than 5, that would mean getting a 6 only. How many? There's only 1 item that will satisfy the condition. Therefore, the probability of getting a number greater than 5 is 1/6, which is already in simplest form. Okay, so let's continue. What is the probability of getting a number less than 7? Again, we know that the sample space are actually made up of 1, 2, 3, 4, 5, and 6. Now, note that if it's a probability of getting a number less than 7, then that would mean any number from 1 to 6 will satisfy the given condition. And that's everything in our sample space. Therefore, this will be equal to 6/6 or equal to 1. Oh, teacher, is it possible to have 1 as a probability of an event? Yes, it's possible. Just like what we did. That is when the event is certain to happen. Okay, next. What is the probability of getting a 7 when we roll a die? I don't think it's possible because a die only consists of numbers 1 to 6. 7 and above is not present on a 6-sided die. Therefore, the answer would be 0 chance out of the 6 outcomes. That means it's 0. The probability is 0 because there's 0 chance that the result will be a 7. This time, let's go to another problem. Example 3. Following table shows the number of female and male students in the grade 9 and 10 classes for a certain school, and the data is shown on the table. If a student is randomly chosen, what is the probability that the student is a male? So we're getting the probability that the student is a male, but it doesn't identify whether it's a grade 9 or grade 10 student. So we are sure that it will be all the male regardless of the grade level. That would mean it's 350 over 1,000, which is equal to, let's use our calculator in that case. Okay, so if we're going to do that, that would be 350 divided by 1,000. And the answer is 7 out of 20. So there's 7 out of 20 chance that a randomly selected student is a male. Okay, let's have another one. How about the probability that it's a grade 10 student? Again, it's regardless whether it's male or female. Therefore, we're going to take the total of grade 10 student, and that's 550. So we have 550 divided by 1,000. Let's use our calculator. 550 divided by 1,000 is equal to 11 out of 20. So there's 11 out of 20 chance of getting a grade 10 student when a student is randomly chosen from the given set of data. A bag contains 8 pink, 9 black, 6 green, and 11 orange balls. If a ball is randomly drawn from the bag, what is the probability that it is black? So to get the probability, A is equal to probability that it's black. First, let's identify how many balls do we have all in all. So we have 8, 9, 6, 11. If we add all of those, we have 34 balls. So let's put this aside first. So if we have 34 balls and out of the 34 there are 9 black, then the probability is 9 out of 34, which is already in simplest form. So the probability that a ball is drawn from the bag and the probability that it is black will be 9 out of 34. What is the probability that it will be a pink ball? That would be, since there are 8 pink balls, so it's 8 out of 34, or let's simplify that further, it's equal to 4 out of 17. So the probability of getting a pink ball is 4 out of 17. Let's go to letter C. The probability of getting an orange ball, which is equal to 11 out of 34, since there are 11 orange balls and there is a total of 34 balls in the bag. So that's 11 out of 34, which is already in simplest form. So what is the probability of getting a green ball? The chance or the probability that it will be a green ball is 6 out of 34. This can still be simplified further to 3 out of 17. So the probability is 3 out of 17 of getting a green ball. So this is a simple problem, no? But let's take a look at the different rules in probability. Notice that the probability can actually, all the probabilities that we come up with from the first example is either a fraction or 0 and 1, correct? So we have a fraction here. What kind of fraction is this? Yes, exactly, it's a proper fraction. All the values here are proper fractions as well. 1/2, 1/3, 1/6. But we can have a value of 1 and 0. Okay. We can also, this is also a proper fraction. So that means the values of the probability, all of these are proper fractions. So the values of probability can be 0, can be 1, or any proper fraction. Remember, a proper fraction is a fraction whose value lies between 0 and 1. Therefore, Rule 1, the probability of an event E is a number between and including 0 and 1 denoted by this particular symbol. So that means in terms of decimals from 0 to 1. But when we talk about percent, so because probability can be in percent form, right? Just like what we talked about earlier. So that would be 0% up to 100%. Next, the probability of an event E cannot occur if the event does not contain anything in the sample space. Exactly. So the probability in that case is 0, just like this example. I think we had previous example, but let's look at the example here. When a single die is rolled, what is the probability of getting a 23? That would not be possible. Why? Because a 6-sided die would only have up to 1 to 6 outcomes. So getting a 23 is not possible. Therefore, we can write it as the probability of getting a 23 is equal to 0. Next, Rule 3. If an event is certain, then probability of E is 1. Okay, just like the previous example, what is the probability of getting a number less than 7 if a die is rolled? This is actually 100%. Or the probability of getting a 7 is equal to 6 out of 6, which is 1. Or there's a 100% chance that when you roll a die, the values that you're going to get are less than 7. Okay, so that's rule number 3. Rule number 4. The sum of the probabilities of the outcomes in the sample space is 1. Let's have this example. So we have the probability of getting a head and the probability of getting a tail are all the outcomes in getting a head and getting a tail are the outcomes when we toss a coin. So basically, if we add these probabilities, it says in rule number 4 that the result will be 1. The probability of getting a head is 1/2. The probability of getting a tail is also 1/2. When we add this, the result will be 1. Is it the same when we throw a die? Let's say. Is it the same when we throw a die? We know that there are 6 sample spaces. Let's get the probability of each sample space. The probability of getting 1, the probability of getting 2. Add it to the probability of getting 3 and 4, 5, and 6. Let's check what will be the value. This is 1/6 plus 1/6. There's 1 out of the 6 chance that the result will be a 3. Same as with 4, 5, and 6. So the result is 6/6 or 1. That is what we mean by rule number 4. But how do we apply it in rules of probability? Rule of complement of an event in probability. We know that the probability of an event plus the probability of its complement is equal to 1. Therefore, either way, probability of the complement is actually equal to 1 minus the probability of that event occurring. At the same time, the probability of the event is equal to 1 minus the probability of its complement. Let's take a look at example number 9. If a probability that a person resides in a condominium unit is 1/5, find the probability that a person does not live in the condominium. If you don't know that the sum of the probability and its complement is 1, then this will be a challenge question for you. But since we know that to get the probability of those who do not live in a condominium is simply equal to 1 minus the probability of the event, which is the probability of the person residing in a condominium, which is 1/5, then it's simply 1 minus 1/5, and that would give us 4/5. So there is 4/5 chance that a person do not reside in a condominium unit. This had been a great learning adventure.